So if you see this, we have a very interesting continuum which we talked to Pay about. We all talked about data in 80s being stored in structured formats like databases, right? We had tools like Excel, we had tools like Oracle, we had tools like MySQL, we talked about Oracle, all that is relational databases. What it gave? It gave us a structured approach to look at data. What is important there? Important there is the schema, which is basically what is the structure of the columns, what is the structure of the entries of relations you're talking about modeling in the real world. How do you capture real world data into a table? Then came the era of what you call BI, business intelligence, right? We talked about how do you create a common view of the customer across multiple databases. That's where we talked about information-centric approach. But now today, when we're talking about a lot of historical data being compressed into something intelligent, which is very small, concise, that's called knowledge. Knowledge-centric approach to data. That's what AI is all about. Creating concise, succinct knowledge from a lot of historical data. Then when talk about wisdom, it's about also taking the next step. Can I create autonomic program which is able to act on itself without necessarily a human in the loop? That's what is wisdom all about. Autonomous driving car. Autonomous program like the, Watson. Program was not waiting for a human to expert. So here there is an interesting component which is coming up, which is called analytics. All of you heard of analytics, right? Analytics stops at knowledge. They use similar algorithms. Believe me, people talk about data science, analytics being different from AI, ML. That's the biggest misnomer. Most of the textbooks which teach data science and business analytics, they use the same algorithms as an AI program would do. Not different. But the way they approach is they stop at knowledge and then let an expert take over. A human takes over. Human will take the action after the output of the knowledge extracted. That's what is the analytic stream of things. The stream of things empowers the human or the knowledge worker to take the action. It does not autonomically replace the knowledge worker. Whereas in the wisdom, we talk about autonomous program which can take the intelligence and do an action also. For example, today in financial services, how many of you, I don't know, many of you must be working, there are programs where a risk manager will get all the inputs, but he will take the call. But in robo-advisors, or in algorithmic trading, or in autonomous straight-through risk undertaking kind of programs in insurance, etc., the program itself takes the decision because it's empowered with enough intelligence and it can be overriding any human. So this is a very interesting dichotomy when we start about. So and then there is one more word which people talk about when you stop at the human, at the knowledge level. It's called intelligent augmentation. It's not AI, it's IA. Means there is a human or a knowledge worker who is being augmented in improving his worker productivity by the knowledge extracted from the lot of raw data. So these are all different ways of looking at it. But today, when we say AI, people often confuse that you have to always work at the wisdom level, where there's an autonomous program. Need not be. It can even be very rich analytics, which is given as an input to ultimate knowledge worker. It could be a doctor who is going to take, or a radiologist who is going to take final decision. So don't always think that AI programs have to be always autonomous or automatic. It can always also be augmenting a particular expert. Because there are some areas in which governments are not allowing it. There are legal issues by which you cannot allow a completely autonomous program to do certain tasks. So there, a last mile has to be an expert who uses the intelligence data. So productivity will increase. Like he was doing 10 patients, now may do 100 patients. But improved performance because of the availability of the right knowledge at the right position for him to take an informed decision. That is important. So like that, we also have seen different kinds of people who come from the data science school of thought talk about different analytics. Descriptive is simple statistical thing. Inferential is where you try to talk about how to sample from a large population. Exploratory is about understanding what the data can tell you, the stories data can tell you, without necessarily doing complex analytics. Predictive analytics is where we talked about the knowledge extraction. So there is a strong relation between the statistical school of thought of predictive analytics and the knowledge extraction which we talk about in AI. So AI and statistics are very closely tied to each other. So people say this is different, that's different. No. So sad part is the MBA schools are teaching business analytics with same algorithms which AI schools teach. But they call it business analytics, these guys call it AI and machine learning. We have to end this. We all have to work together. Domain guys, business analysts, and data scientists have to work together. Unless you get the right questions of what from your domain experts, any AI applications is useless. You will solve the wrong problem if you don't have the right questions. If you don't have the right problem formulations. It's like getting your requirements right. Just like a software development, there's a life cycle, which we'll cover.